Hi, today we are going to see the topic rate of change of velocity, which is nothing but acceleration. And we have learned what is velocity. It is a speed with direction. So, if there is a change in speed and direction of an object which is in motion, then there will be acceleration. Can we measure this acceleration? Yes, we can measure the acceleration. Let us see with an example how to find out the acceleration of an object. So, consider an object which is starting at a point A and it travels to a point B in time t seconds. Now, the object which is at its initial position will have initial velocity and it is represented using the letter u. An object which reach its final position, it will have some final velocity which is represented by using the letter v. Now, the acceleration a can be written as, see, if you see the rate of change of velocity, usually wherever you see rate, it will be per time. If you see the word rate, it will be per time. So, here it is change of velocity. Change of velocity means the difference between two velocities, that is the change between two velocities. So, what is the change of velocities? We have final velocity and the initial velocity. So, the change of velocity will be v minus u divided by, since it is rate of, I told you it will be per time. So, it is v minus u by t, where v is the final velocity, u is the initial velocity per time. Now, the SI unit of acceleration. You know that the SI unit of velocity is meter per second divided by the SI unit of time is seconds. So, you will get meter per second square, which can also be written as meter minus 2. So, the SI unit of acceleration is meter per second square. Now, acceleration is a vector quantity. You know, the velocity we have already discussed, velocity is a vector quantity and time is a scalar quantity. Therefore, acceleration is a vector quantity. Hope you understood. Acceleration is nothing but the change in speed or direction of an object which is in motion. Now, let us understand more about acceleration. In first case, let us consider an object travels from the point A to a point B with constant speed of 40 meter per second in 5 seconds. An object is travelling from point A to point B in time t seconds with a velocity of 40 meters per second. That is 40 meters per second throughout his travel. Okay? So, the object is moving with the same constant speed. So, in that case, what will be the acceleration? Let us substitute in the formula and find out what will be the acceleration. So, from the formula we know that A is equal to v minus u by t, which is equal to, what is the final velocity? Here throughout it is going with a constant velocity. So, the initial velocity and the final velocity are both same, which is nothing but 40 meter per second. So, final velocity is 40 meter per second minus 40 meter per second divided by time, it is 5 seconds. Therefore, you get 0. So, the answer is 0. So, from this what did we understand? An object with constant speed, an object which is moving with constant speed, what will be the acceleration? The acceleration will be 0. Now, let us consider second case where an object travels from a point A to a point B, but initially it will have a velocity of 40 meter per second and it travels, and by the time it ends its destination, its final velocity will be 80 meters per second in time 5 seconds. In a time 5 seconds. So, here what will be the acceleration? The acceleration will be A is equal to, what is the final velocity here? Final velocity is 80 meter per second minus, what is the initial velocity? Initial velocity is 40 meter per second divided by time 5 seconds. So, we will get 40 by 5, 8 meter per second square. What are we getting? When the speed increases from initial point to the final point, we have got 8 meter per second square, which is nothing but it is a positive value, right? This is a positive value. Now, let us consider the third case where the object starts from a point A and it travels to a point B, but initially in this case the speed where the object started was at 80 meter per second, and by the time it reached its destination the final velocity was 40 meter per second. Can you see? Here the initial velocity is 80 and the final velocity is 40 in a time 5 seconds. Now, what will be the acceleration? Acceleration is equal to final velocity, which is 40 meter per second, minus initial velocity, which is 80 meter per second, by 5, which is nothing but minus 8 meter per second square. So, when the speed decreases, what the value what we got is 8 minus 8 meter per second square, which is a negative value. From this, what can we understand? The acceleration will have a value of 0, or it can have a positive value, or it can have a negative value. And when A will be 0? When the object is moving with constant speed. Speed increases, the acceleration value will be positive. When the speed of the object decreases from initial velocity to final velocity, the value of acceleration will be negative. Now, let us see one more case. Okay, now let us see an example. Here the object starts from a point A and reaches to a point B with a constant speed. Here the speed is constant. Let us take 40 meter per second. So, the object travels from point A to point B at 40 meter per second. And throughout the object is traveling at 40 meter per second speed. Okay. Now, can you guess will there be an acceleration? Because previously we have told in the first case that at constant speed the acceleration will be 0. But in this case, do you think the acceleration will be 0? No, here the acceleration is not 0. If you remember, well, in the beginning of the class, I told you what is acceleration. If there is a change in speed or direction, then there will be acceleration. Here, can you see the change in direction? The speed is constant, but what about the direction? Here, the A travels in one direction till this point and it turns and it takes a different direction. So, in this case, there is a change in direction. Even though the speed is constant, there is a change in direction. Since there is a change in direction, there is acceleration. So, let us put all together once more. At constant speed, the value of acceleration will be 0. As the velocity increases, the value of acceleration will be positive. and as the velocity decreases, the value of acceleration will be negative, and negative acceleration is also called as deceleration. Negative acceleration is also called as deceleration. And if there is a change in direction, there will also be acceleration. Now, let us learn the difference between uniform acceleration and non-uniform acceleration. So, what is uniform acceleration? If an object travels at equal velocity at equal intervals of time, then it is called as uniform acceleration. And here, non-uniform acceleration is if an object travels with variable velocity at equal intervals of time, then it is called as non-uniform acceleration. That is, see, in equal intervals of time, at equal intervals of time, the velocity is increasing equally. See, the difference between it is 2 meters per second. That means the velocity is increasing equally from a point A to a point B. It is continuously increasing. It is increasing, but how is it increasing? It is increasing equally. Then it is said that the object moves with an uniform acceleration. Don't get confused between constant velocity and equal velocity. From point A, it moves to point B, maybe say like 30 meters per second. So, throughout the journey, the object will be moving only with one speed, that is 30 meters per second. That is what we call it as the object is moving in constant speed. But here, the object is equally increasing its velocity. And you know, only when there is a change in velocity, we say there is a acceleration. So, here the change in velocity is equal. So, that is what we say an object travels at equal velocity at equal intervals of time. Now, coming to non-uniform motion. In non-uniform motion, an object travels with variable velocity at equal intervals of time. Here you see, here the time period is equal, whereas the velocity is different. See, the object is moving with a different velocity. In that case, it is said to be in non-uniform acceleration. So, this is what is uniform acceleration and non-uniform acceleration. So, hope you understood, and let's see few problems related to acceleration. Starting from a stationary position, Rahul paddles his bicycle to attain a velocity of 6 meters per second in 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second in next 5 seconds. Calculate the acceleration of bicycle in both the cases. So, here in the question they have given you two different cases. So, let's see. Starting from a stationary position. What does this mean? From stationary position means the object, initially it is at rest. So, starting from a stationary position, Rahul paddles his bicycle to attain a velocity of how much? 6 meters per second. So, the speed is 6 meters per second in how many seconds? In 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meters per second, and from here he applies brake, and so he goes with a velocity of 4 meters per second in the next 5 seconds. So, in first case, since Rahul is starting from his stationary position, the value of u will be 0, and the value of v, since he is attaining 6 meters per second speed, the final velocity will be 6 meters per second, and the time t will be 30 seconds. Okay, by applying the formula, that is, what is the formula of acceleration? A is equal to v minus u by t. Therefore, by applying this, A is equal to what is final velocity? 6 minus initial velocity 0 by 30. So, you will get 1 by 5, which is equal to 0.2 meter per second square. This is the unit of acceleration, and we are finding acceleration. So, what is acceleration? It is 0.2 meter per second square in the first case. First case in the sense we are starting from the initial point to a particular point. Now, let us see the second case. In second case, what is it saying? In second case, from this point, he applies a brake. So, what is happening to the speed? The speed is decreasing. The speed is decreasing. After applying a brake, the speed is decreasing. So, when he applied a brake, what was his initial velocity? See, he was coming with a speed of 6 meter per second, right? So, when he applied brake, the initial velocity is 6 meter per second. Now, the initial velocity will be 6 meter per second, because when he applied brake, actually he was traveling with 6 meter per second speed. So, in second case, the value of u will be 6 meter per second, whereas the value of v will be, by the time he applied a brake, the speed was decreased to 4 meter per second. So, the final velocity will be 4 meter per second, and the time t will be 5 seconds. So, again applying the formula for acceleration, acceleration is equal to v minus u by t, where the final velocity is 4 minus initial velocity is 6 by 5. You will have minus 2 by 5, which is equal to minus 0.4 meter per second square. And see, here you can see the value is negative. And when will we get a negative value? If the velocity decreases. See, here the velocity is decreasing. First, initially it was 6 meter per second, and it is decreasing to 4 meter per second. So, if the velocity is decreasing, we will get a value of acceleration as negative. So, this is they have asked to calculate the acceleration of bicycle in both the cases. We have calculated it. In the first case, the answer is 0.2 meter per second square, and in the second case, the answer is minus 0.4 meter per second square. Our next problem is the train starting from a railway station and moving with uniform acceleration attains a speed 40 km per hour in 10 minutes. Find its acceleration. So, what they have given, the train is starting from a railway station. Since the train is just starting at railway station, it definitely would have been at rest, right? So, the initial velocity of the train will be 0 and attains a speed of 40 km per hour. So, it moves and attains a speed of 40 km per hour. That means its final velocity is 40 km. So, v is equal to 40 km per hour. And what is the time it has taken? It has taken 10 minutes. And now they are asking you to find the acceleration. As usual, you know the formula for acceleration. A is equal to v minus u by t. But before applying the values into the formula, we have to convert, because the SI unit of velocity is meter per second and the SI unit of time is seconds. And here they have given in kilometer per hour, where we have to convert into meter per second, and here they have given in minutes, which we have to convert into seconds. So, we have already learned how to convert. So, converting velocity, which is 40 km per hour. So, to convert, what should we do? We have to multiply 5 by 18, which is equal to 11.11. Now, how do we convert minute into seconds? We know that 1 minute is equal to 60 seconds, right? 1 minute is equal to 60 seconds. So, we have to convert 10 minutes. So, what will 10 minutes be? 10 minutes will be 600 seconds. Now, we will substitute that in our formula. We know that A is equal to final velocity minus initial velocity by time t. So, which is equal to, what is our final velocity? It was 40 km per hour. We have converted into meter per second, and it is 11.11 minus our initial velocity is 0 by time they have given 10 minutes. We have converted into seconds and now it is 600 seconds. Therefore, you will get 11.11 by 600 which is equal to 0.0185 meter per second square. Remember this, meter per second square, the SI unit of acceleration. So, as per the question, they have asked us to find the acceleration and we have got the acceleration. So, in problems, the main thing what you have to keep in mind is, if they have given in kilometer per hour or in minutes or hours, you have to convert that into the SI unit. SI unit of velocity which is meter per second and SI unit of time which is seconds. And the next thing what you have to keep in your mind is acceleration. Never forget to write the unit of acceleration which is meter per second square. In today's class we have learnt rate of change of velocity which is nothing but acceleration, and the difference between uniform acceleration and non-uniform acceleration. Then we have seen few problems on acceleration. And if you have any doubts, you can put it in the comment box. And if you really like this class, please subscribe and share it with your friends. Thank you.